In this video, we're going to look at separable differential equations. Consider a first-order differential equation of the form dy dx is equal to f of xy. If we can factor dy dx as a product of a function of x and a function of y, then we can write dy dx as f of x times g of y, a function of x multiplied by a function of y, f of x times g of y. Then we call this a separable differential equation. Given an initial condition y of x0 equals y0, for example, y of 0 equals 2 or y of 1 equals negative 3, we obtain a separable differential equation with an initial condition y of x0 equals y0. So the key concept is that a differential equation is separable if we can write it as a product of a function of x times a function of y. All right, so what is the general strategy? The general strategy is dy dx, given dy dx is equal to f of xy and y of x0 equals y0. This is an initial value problem. We have a differential equation. We also have an initial condition. So the first step is to factorize dy dx as a product of a function of x times a function of y. So f of x times g of y. The second step is to put all the y's on one side and all the x's on the other side. Separate f of x and g of y. The reason for that is that way we can integrate both sides. That's the next step. So the next step is to integrate both sides because now we have separated the variables, so we can just integrate 1 over g of y dy on the left-hand side, and we can integrate f of x dx on the right-hand side. Step 4 is to solve for y as a function of x. So make y the subject as an explicit solution, but sometimes that's not possible. So we'll leave the answer in implicit form. Step 5 is apply the initial condition y of x0 equals y0 to find the arbitrary constant c of integration, because whenever you integrate, you're going to get a constant of integration, constant c coming out. So let's look at an actual example. Here we have find the solution of the differential equation dy dx is equal to x cubed y with the initial condition y of 0 equals 2. The first step is to notice that we have a product of x, which is x cubed, times a product of y. So this is in fact a separable differential equations. So let's separate the variables. Dy divided by y is equal to x cubed dx. So this is just a bit of algebra, putting all the y's on one side, all the x's on one side, basically divide both sides by y, and then multiply both sides by dx, and we get this expression. So now we have to integrate both sides. If we integrate both sides, we get integral of dy over y and integral of x cubed dx on the right-hand side. What is the antiderivative of 1 over y dy? That is log of y, because derivative of log y is 1 over y. And integrate the right-hand side, reversing the power rule, integral of x cubed is equal to x to the 4th, divide by 4. And we put the constant of integration on the right-hand side, on the side of the independent variable. So that's just arbitrary. I mean, in the sense, when you integrate both sides, you get constants coming out on both sides. But you can just bring everything to the right-hand side and just put the constant on the side of the independent variable, which is x in this case. All right. So now the next step is to remove the log, and we do that by exponentiating both sides. So we get e to the log of y is equal to e to the x to the 4th over 4 plus c. Now let's rewrite this as e to the x to the 4th over 4 times e to the c. Notice the constant that's additive becomes multiplicative, and this has to do with the exponential law. E to the a plus b is equal to e to the a times e to the b. All right, so e and log cancel, we get absolute value of y is equal to, now let's write e to the c as another constant, let's say k. So that's k times e to the x to the 4th over 4. Let's label that k is equal to e to the c. Now let's remove the absolute value, and we're going to get y is equal to plus or minus k e to the x to the 4th over 4. And plus or minus k, we can just call it another constant. Let's say b. b is equal to plus or minus k. So we get y is equal to b e to the x to the fourth over 4. All right, so now how do we determine b? We have y of x is equal to b e to the x to the fourth over 4. At this step, we go to the initial value of the question, initial value condition of the question, which is y of 0 equals 2. It's very important that we interpret this correctly. This means when x is 0, y is equal to 2. That means we can plug in y equals 2 for y and x equals 0 for x into our equation and solve for b. So we get y is equal to 2 is equal to b e to the 0. E to the 0, of course, is 1. So we get b is equal to 2. So the solution is y of x is equal to 2 e to the x to the fourth over 4. This is a solution of the differential equation that we were given. So we were given dy dx is equal to x cubed y, and we recognize this as a separable differential equation because we have a function of x times a function of y. We were given an initial condition, y of 0 is equal to 2. So this is called an initial value problem. We solve this differential equation, and the solution is y as a function of x, explicit solution, y as a function of x, is equal to 2 e to the x to the fourth divided by 4. That's the solution. All right, thanks.